So we have x plus y is equal to what? 20. And what equation do we want to maximize? What equation do we want to maximize? It tells us right here. What equation? X times y. So let's give it a name. Anybody want to give it a name? You can pick any name you want. Z. So z is equal to x times y. How many variables are right there? 2. How many variables do we want? 1. So what do you want to isolate in the top equation, Connor? Which one do you want to isolate, x or y? What's x going to be? 20 minus? Where are we going to plug that in? So what does z equal? 20 minus y times what? Times y. This is what we want to maximize right here. That's what we want to maximize. So we're going to take the... But before we take the derivative, what should we do first? Yeah. Yeah, do it out a little bit. So what does z equal? 20y minus y squared. So now we take the derivative. Zach, what's the derivative?
20 minus 2y.
2y. Now what do we set that equal to?
0.
So 0 equals 20 minus 2y. You can just tell me, what does y equal? 10. We should do the sign check, right? A sign chart. So where do we plug it into? Where's z prime? Oh, z prime is right... Let's do this here. Where's z prime? Z prime is right there. What's the smallest y could be? What's the smallest y could be? Well, theoretically, it could be 0. Does it say positive? Yeah, 2 non-negative, so it could be 0. What's the highest it could be? 20. So we need to plug numbers into 20 minus 2y. So what's between, oh, we thought it was not y. We think it's 10 right here. We know the derivative is 0 right there. What is it to the left, everybody? What is it going to be? It's going to be positive, right? But if you go to the right, what is it going to be? It's going to be, oh, I just chose the same highlighting. That's going to be negative. So what does that mean? It's rising and then what? What's it mean?
Falling.
It's rising and then falling, so it's going to be a max. So we just proved that y equals 10 is where the maximum occurs. And if y equals 10, what does x equal? Y equals 10. So what do we have? X equals 10 and y equals 10. And we proved it. Was the algebra pretty comfortable in this one? Sure. Now, the other set of questions here, all it does is changes a little bit about what you're trying to minimize or maximize. So example, for B, it says x squared y is as large as possible. The numbers still add up to be 20. So what does x plus y still equal? Still equals 20. So in this case, what's z going to equal? Well, which one do you want to isolate, x or y? So y is equal to 20 minus x. So we have, in this case, what is z going to be equal to? X squared times what?
20 minus y.
20 minus x. Is the process exactly the same this time, except a little tiny bit different in terms of what we're multiplying? So Lizzie, what does z equal? What do we do now before we take?
20x squared
Yep.
minus x cubed.
Yep, and then we take the, so what's the derivative, Lizzie?
40x
Yep, minus.
2x or 3x
Yep,
squared.
and what do we set that equal to, Lizzie?
0.
So we have 40, oh, this is stuck, sorry. 40x minus 3x squared is equal to 0. What should I factor out there, Lizzie?
An x.
Yeah, so we had x is 40 minus 3x equals 0. So x is equal to 0, or x is equal to, what's x going to be for this one? 40 over 3? Oh, look. I left the sign chart there just so you could see it. So you get those two numbers. If x is 0, why is it problematic if x is 0?
Well, there isn't.
It's going to be 0. Like, what's 0 times anything? 0. So it's definitely not going to be there. So we hope that this is a what? We hope that's a what? We hope that that's a max. And what does this sign diagram tell us about? This is that right there, everybody. That is equal to 40 over 3. What does this sign diagram tell us, Henry? What happens here at 13 and a third? It's a max. So it's up and then down. So we have our that's our x value. And then how do you get the y value? Well, we know that we want to get rid of x or y.
Y equals negative x squared plus y.
Exactly. We have y is equal to negative x squared plus y. We can put it right there. So tell me what the new equation is going to be, Henry.
A equals x plus 1
Mm-hmm.
times negative x squared plus 9 plus 1.
Yes. And how many variables do we have now?
1.
So before we differentiate, what would we need to do first? Simplify. Sit down and simplify this for me. Just have to be aware of. The restrictions, right? Look what it says here. The lower left-hand corner of the rectangle is at that point, and the upper right is in the parabola where x is between 2 and 3. Did everybody see that right there?
Yeah.
Where x is between 2 and 3. We got two numbers. Are either one of them between 2 and 3? They're both outside of it.
So we have to.
Just test what?
2.
The endpoints. 2 and 3.
So why did we just do that?
Because we didn't know for sure if there was a max or min in between the two. We didn't know if the max was between. Again, can we have a feeling about it? Sure, but what are we doing? We are proving it.
Wait, so the max